Hey guys, Mr. Holman here for our new lesson this week on rational expressions. So far in this unit, we've talked about simplifying, multiplying, dividing, and adding and subtracting rational expressions. And now what we're going to do is we're going to take all those things that we've talked about and those skills, and we're going to apply them to equations that involve rational expressions. Now you have already solved equations involving rational expressions before when you were in Algebra 1. In fact, the place that you probably talked about them was when you talked about solving proportions, because as you can see here in our first example, 2 over x equals 5 over 3, this would be an equation that involves rational expressions because we have fractions, and it's really a proportion because we have a ratio equal to another ratio. And what we're going to see is that when we solve these types of equations, there's two basic ways that we can solve. The first way involves cross multiplying, and we're going to use that process specifically whenever we have one fraction on each side of the equation. And in this case, we have just that. So what we're going to do to solve this one is we're going to cross multiply. But in general, our second way of solving, which we're also going to see today, is that we can cancel out using the LCD. And when we say cancel out, we're really going to multiply each term by the LCD. And last year in Algebra 1, when you talked about cross multiplying, you may have discussed that this second method of canceling out the fractions is really what we're doing when we're cross multiplying. We're just taking out a couple of steps. So in general, to cross multiply, what we're going to do, let's undo that for a second. What we're going to do here is we're going to take the denominator of the right times the numerator of the left. That's going to give us 6. And we're going to take the denominator of the left times the numerator of the right, and that gives us 5x. And from there, we're going to solve the resulting equation the way we normally would, which means in this case, we're going to divide both sides by 5. And that'll leave us with our answer of x equals 6 over 5. That would be our final answer, and if we would plug it back in, we would see 2 over 6/5 is the same as 5 over 3. Now there's one extra thing that we actually have to do that we should have done at the beginning, and that is to make sure that we always want to, if this erases, it's not going to, we always want to make sure that we state our restrictions at the beginning. So we're going to have to state restrictions on our solution. And we didn't have to do that prior to this because we weren't solving equations. But here, now that we have an equation, we want to make sure that we say what would not be an acceptable answer for x. And in this case, what would not be an acceptable answer would be whatever number causes my fraction to be undefined. Which means if I look at the denominator here, this x in this case, since it's in the bottom of that fraction, I would say that x cannot equal 0. Because if it did, this whole fraction would be undefined. We're going to see in other cases that our restriction's a little bit different. We might have to solve for it. But this is our basic process. So we're looking at something that you did before and we're going to add on to it. Let's take a look for a second at our general steps as far as solving these types of equations. So as I just said, we have two basic ways we can solve. We can use the cross multiplying process that we just saw in that first case, or in most cases what we're going to be doing here is we're going to be canceling out by multiplying by the LCD. So we have 3 steps. First, we're going to find the common denominator of all the fractions in the equation, and we're going to multiply each term by the LCD. When we do this, it should allow us to cancel out the fractions. So we saw when we were multiplying, if we had common factors in the numerator and denominator, they would cancel each other out. That's basically what our first step is going to ensure. We want to make a note here though. As we've seen throughout this unit, we might need to factor the denominator first to help us find the LCD. So we might want to make sure that we do that first. Step 2. Once our fractions are cleared, we're going to solve the equation as we normally would. And we're going to follow the steps for either linear or polynomial equations accordingly. So in some cases, we'll get a linear equation. We're going to use our inverse operations. We're going to make sure that we get the variable on one side and the number on the other. If it's a quadratic equation that we're left with, then we're going to factor, or we're going to try the quadratic formula. We're going to follow those rules where we get the variables and all the terms on one side and we get 0 on the other. And we're going to go through that process that we talked about earlier this year. And then step 3, this is the important one, because what we have to do is we have to check for and eliminate what we call extraneous solutions. So an extraneous solution would be something that seems like it works, except it's one of our restricted values. And that's part of the reason that we state that at the beginning, to tell us, wait, this answer is not acceptable. And that's our 3 steps. So let's take a look at some examples. We're going to use both methods to solve in different cases, but let's work through these together. All right, so here's what we're going to do. In number 2, we have 2x minus 1 over x plus 3 equals 3 over 7. So my first step is always going to be to look for the LCD, unless I have a case like I have here. I'm going to say the LCD is not applicable because we only have 2 fractions. If I had more than 2 fractions, then I would be looking for the LCD. But in this case, I'm just going to use that process of cross multiplying. So I'm going to take the 2x minus 1 times 7, and I'm going to take the 3 times the x plus 3 eventually. The other first step I need to do is figure out what is my restriction for this case. And in this case, I have 7 on the right here. That's fine. That doesn't need to be messed with because it can't be anything other than 7. But on the left, I have x plus 3 in the denominator. That's not allowed to equal 0, which means what value for x would make that 0? That would be negative 3. So x cannot be negative 3 in this case. So we're going to go through and solve. As long as I don't end up with negative 3 for x, we should be good. So we're cross multiplying. We have the 7 times the 2x minus 1 equals 3 times x plus 3. So we're going to distribute on both sides. We get 14x minus 7 equals 3x plus 9. And we're going to get the variables on one side, get the constants on the other. So I'm going to subtract the 3x here and here. I'm also going to add the 7 to the left and the right. So that leaves me with 11x equals 16. Last step, to get rid of the 11, we're going to divide. And we get x equals 16 over 11. My restricted value, remember, was that x couldn't be negative 3. I got 16 over 11. Or if you wanted to write it as a mixed number, 1 and 5/11ths, that would be okay. I would stay away from decimals, using improper fraction first and foremost, maybe a mixed number. Let's look at another example. So again here in number 4, we have x plus 4 over x minus 1 equals x plus 5 over x minus 6. My LCD, not applicable because I have a fraction equal to a fraction. Again, we're going to cross multiply. My restrictions in this case, here I actually have 2 restrictions. And again, restrictions means focus on the denominators. Take a look at the expressions in the denominators. So one of my restrictions is that x minus 1 can't equal 0. And if that's the case, that means x cannot equal 1. The other restriction comes from the second fraction, which is that x minus 6 can't equal 0. Or x cannot equal 6. All right, so we're going to cross multiply here. So let's go ahead and take the x minus 6 times the x plus 4. And since I have a binomial times a binomial, I'm going to have to FOIL there. On the other side, I'm going to do the x minus 1 times the x plus 5. So let's go through and FOIL here. On the left-hand side, we're going to get x squared minus 2x minus 24 equals x squared plus 4x minus 5. Now my first instinct is to think, uh-oh, I see quadratics. I'm going to have to factor this. However, if I try and move the quadratic term to the same side, So let's say I try and subtract the x squared over to the other one. Oh, they both cancel each other out, so I don't have to worry about those. So now it's just a linear expression. I'm going to subtract the 4x over to the left. I'm going to add the 24 to the right. So now on the left-hand side, we have negative 6x equals, on the right-hand side, we would have 19. And we're going to divide by negative 6. X equals negative 19/6, or again, if you want to write it as a mixed number, negative 3 1/6. Neither of those are restricted values, so that's our final answer. Let's go ahead and move on to our next example. Alright, so in our new example here, we have n over n plus 1 equals 2 minus 1 over n plus 1. And in this case, I am going to use that second method of canceling out fractions by multiplying by the LCD. The reason I'm going to do that is because I actually have three fractions here. I have the n over n plus 1. I have the negative 1 over n plus 1. But then I also have 2. And you might be saying, well, that's not a fraction. Remember, it is. It's technically 2 over 1. So while I could combine these two fractions over here, figure out what to add together and combine those, let's just use our second method of solving, which is to use the LCD, and we're going to multiply everything by that to get rid of the fractions. And the reason I'm going to do that in this case is because my LCD is made up of n plus 1, 1, and n plus 1. My LCD is simply n plus 1. So we're going to multiply everything by that expression. So I'm going to multiply here by n plus 1, and I'm going to multiply both of those things by the n plus 1. And it's important to note, this is not like what we did before where we multiplied top and bottom. We're multiplying by n plus 1 over 1, so that way it cancels out with the denominators there. So we're going to get back to that in a second. Before we do, our restrictions in this case, the original denominators of n plus 1, not allowed to equal 0, which means n cannot equal negative 1. All right, so let's get back to what we were doing up here. So we're multiplying everything by n plus 1. On the left-hand side of the equation, the n plus 1's cancel each other out, and it just leaves us with n. On the right-hand side, I have to multiply this expression by n plus 1, and I have to multiply here. So when I multiply the 2, it's nothing to cancel out with because the denominator is 1, so I'm going to do 2 times n plus 1. And then minus, in this case, the n plus 1's cancel again, so I just have minus 1. So now we're going to distribute here on the right. So we have n equals 2n plus 2 minus 1. We're going to combine our like terms on the right. So we get n equals 2n plus 1. And we're going to subtract the variable over. So we'll subtract the 2n. So we end up with this expression here of negative n equals 1. Problem is I don't want to have a negative variable. I want a positive. So I'm going to divide by negative 1. And what that means is on the left we just get n. But on the right, 1 divided by negative 1 is negative 1. Now normally that would be fine. Except in this case, our restricted value here, n cannot equal negative 1. That means, based on the way this was constructed, that's an extraneous solution. If that doesn't work, that must mean that there are no solutions to this equation. So there will be times when it seems like we should have an answer. We did all the right work, but if I plug negative 1 into those fractions, I would get a 0 in the denominator. That's undefined. That's a problem. So there's a case where we use the second process for solving by multiplying by the LCD, And it turned out our answer was an extraneous solution. Therefore, there's no solutions here. Let's take a look at our final example. All right, so here in our final example, number 6, we have 10 over x squared plus 2x plus 4 over x equals 5 times over x plus 2. Just like we saw in the last case, I now have 3 fractions, which means I can't just cross multiply. I'm going to have to find the LCD, and I'm going to multiply by that to cancel out my fractions. What's going to happen in this case first, though, is my first expression here, 10 over x squared plus 2x. Remember that note, we want to factor the denominator first. So the reason I'm going to do that is because if I factor x squared plus 2x, this becomes x plus, times x plus 2. Well, now when I look at my factors, I have x and x plus 2 in the first fraction. In the second fraction, I have x, which I already have in my LCD. And I have x plus 2 in the other fraction, which I also already have in the LCD. So those two expressions make up my LCD. So now what we're going to do is we're going to multiply everything in here on both sides by x times x plus 2 all over 1. So go ahead, multiply each fraction by that expression, and let's see what cancels out. All right, so on the left side, the first fraction, when I multiply, the x's cancel, the x plus 2's cancel, we just get 10. When we multiply the second fraction, the 4 over x, the x's cancel, but I still have 4 times x plus 2. And on the right-hand side, when I multiply this by the x over x times x plus 2, the x plus 2's cancel, so I have 5 times x. From here, we're just going to solve. It's a linear equation, no quadratics. So go ahead and solve the resulting equation. So you should have 10 plus 4x plus 8 equals 5x. We're going to combine the like terms. So we get 18 plus 4x equals 5x. And we're going to subtract the 4x over. And that's going to leave us with 18 equals x. There's my final answer. But I forgot to check. What are my restrictions in this case? So really, I should have done this at the beginning. Let's go back for a second. My LCD was x times x plus 2. I saw in there x couldn't equal 0. So x can't be 0. That was one restricted value. Also, the x plus 2 could not equal 0, which means x could not equal negative 2. Neither of those were the answer I ended up with. I got 18. There's my final solution. If you have any questions throughout the week as you're working on this, please don't be afraid to reach out to me on Schoology or by email. We're also going to have our weekly Zoom meeting at 1 o'clock on Wednesday, so that would be another great chance for you guys to check in. And again, I hope you're all doing well. Take care. Good luck with this week's assignments, and I'll talk to you guys later.